Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to check properties of tangents and secant to a circle. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me explain you what type of worksheet we will be designing. We will be designing a worksheet to explain the difference between a tangent and secant. A tangent is a line which intersects at one point and secant intersect at 2 points. We will take a circle, we will show them a secant and a tangent from an external point. It can be shown separately also, but we want to prove a result. That's why we have taken a point from outside and we are showing that what is the tangent and what is the secant. PT is the tangent and PAB is the secant. Now what is the connection between this tangent and secant? There is one theorem which tells that length of the secant into its external segment is equal to length of the tangent segment the whole square. From the figure, it is PA into PB is equal to PT square. We will get their values and we will try to explain it to the children, and a child can come and pull and push it. They can make this position also, they can change it at any place, they can change. There won't be any problem. Is it okay? Everything changes, but the final answer does not change. Okay, well, now let us try to design this dynamic worksheet from scratch. For that, I have taken GeoGebra Classify worksheet. I have taken geometry view, and I have taken in the options. You can take labeling of new points and rounding off to either 1 decimal or 2 decimal. It is left to you. But remember, whenever any calculation comes, better to take it in 2 decimal place where so that you will get a most approximation calculation. And I have activated navigation bar. Okay, let us start with the heading for this particular worksheet, so that while you are doing it in the class, you can use this worksheet in a kind of interactive way with the children. Tangent and secant of a circle. Now you can explain to the children that what is actually a tangent and secant. They can recollect the definition of a tangent and a secant. You can ask them to recollect. This is the definition of a tangent. You can tell them that what is actually a secant. Then we will try to draw both of them on a circle. Well, for that, as usual, I am taking a slider. You can no need to take a slider. If you take a slider, you will get different circles, so that a child can enjoy it by having a circle of different radii. Okay, I am taking it. Integer I have taken. There is no need for it. Well, I am going for the circle with center and radius. I am putting the center. The radius I am calling it as small n. Well, I can move it and then get it a little bit big. This normally it will be taken as capital O. Is it okay? It will be taken as capital. Okay. Now let me take a point outside, point on the object. Sorry, point outside. Let me take a point. Let me call it as P. Okay. Let me try to draw one secant to it. For that, let me take a point on the object. Okay, A I have taken. Now let me try to join these two segments. Now these two segments I am joining. Okay, when I move this, you are seeing it cuts, but A is also can be moved. Let me go for this point of intersection to complete that secant. Okay. Okay, now what you can do is if you want to replace it, this is actually point A. this point B, you can remove it, and this you can rename it as B for our convenience only, for that formula PA into PB. No need to worry. Now let us go for the tangent. Now this is a secant. You can prove it to the children. Now if you move it, it's a secant because it is touching at 2 points, therefore it is a secant. Now for a tangent, I think already we have done it, but anyway we will go for it. We will go for this tangent. Let me touch this and then touch it. I will get two tangents, but let me go for only one tangent because I want to just show you only one tangent to children, that PA into PB formula. Therefore I will go for first point of intersection. Let me have the intersection of these two. See, it is coming. Now let me go for this segment. Let me go for this segment. Okay, then let me rename it as PT. This is only for convenience. There is no need for it. Okay, now there is no need for these lines now. Therefore, show the object and then you can show the object. Okay, now there are two things the child is seeing now in this figure. One is PAB and another is PT. Now you can declare to the children that PT is the tangent. You can ask the children that why it is a tangent, because as per the definition, it touches at a single point. PT is a tangent. Now again you can go for the next statement about the secant, and you can ask the children that why it is a secant, why it is called a secant. Therefore it is a secant because it touches at 2 points. Now you can go for the connection between them. There is a connection between them, PA into PB. That can be explained in this statement to the children. Length of the secant. You can write the statement over here. Length of the secant multiplied by its external segment is equal to length of the tangent segment to the whole square. Therefore, what is it? From the figure, the child can figure out. From the figure, it is PA into PB is equal to PT square. Okay. For that, here actually you see, you should be a bit careful. You go to this graphing. I think you can get this length of this PA. I think you see when I right click it, the AP, it is F. You have to remember in your mind that it is F. Okay, 10.4. Okay, now what is this PT? That also you have to remember. It is I. Now these two things which you have to remember. Now we don't have this PB, therefore go to this segment and let us go for it. Drawing. Okay, I think I got it as J. Therefore now you should be a little bit careful. In the text you have to write PA. Therefore what is that PA? It is actually given as a small f. I think already we have seen it. Okay, this is PA. When I will show you once again. When I right click it, you see segment F. Segment F. So you have to remember that. Okay. Therefore PA is from the object, it is F. Okay. Then from the symbol you have to go for this multiplication, then multiplied by, now the new thing have come to you as J is equal to the whole square. I think PA into PB is equal to the whole square. That is actually I. Therefore from the object you have to take that I, then you have to put it as from the symbol the whole square. Okay. When I move it, automatically it goes. Suppose you can show it also over here. Suppose the child wants to show it in the object properties, you can go for it. In that you can go for its value. Okay, it is showing it as 7.28. But remember, one thing you should be very careful here. PA and PB cannot be shown directly. For what you can do is, in that AB you can go, then you can show it to the children that what is AB. PA is equal to, I think from that it is F, from F. Okay, now I think you can put it over here. The child can visualize that, okay, this PA is 10.04. Once again you can write what is PB. I think it is just now we have introduced it as J. Okay, now these two things the child can understand over here. For 10.04 into 5.28 is equal to 7.28 the whole square. Okay, in the input box now we want to calculate the left hand side. I think you got up to ij, therefore we can go for k. Therefore we can go for k is equal to the left hand side. The left hand side is I into sorry, f into j. Therefore you have to type it as f multiplied by, you can put the star, the new variable j. Okay, now you got the idea now. Now the pt square 7.2 the whole square, therefore you can have, I think you got it now. You see in that you got it k. Now k you can have small l is equal to I the whole square, that is I square means the square of that 7.28 pt square, therefore you can have the square of it. Okay, now let us see both of them are equal now. Oh, they are equal now, 53.02 53.02. Therefore now you can go for this ABC over here and you can write it here, k is equal to L. I think no need to do that, k is equal to L because both are one and the same. Okay, anyway I am putting it because I am very particular about it. Okay, now both are coming as equal. Okay, now you can come back to this geometry. You have just made everything. Now you can give a color to this PT also. Suppose go to the object property, give a color to it. Okay, so that the child can understand that what is actually PA into PB is equal to PT square. Therefore, this is a dynamic worksheet where a child can understand what is the difference between a tangent and a secant, and what is the connection between the length of the tangent and its external segment with the length of the tangent segment from an external point. The theorem can be proved in the class, but the result can be verified using this dynamic worksheet. Thank you. Let us learn to lead.